Welcome back. In this part of the course, we're going to focus on generating data using NumPy arrays. This will comprise random as well as non-random data, and we'll explain when to do what. We'll start by examining how to quickly create arrays full of ones, zeros, or any other values we need. After that, we will move on to random data. There, we'll discuss what a random generator is, why seeds are useful, and how to generate a random sequence based on a probability distribution. Lastly, we'll explore some applications of generating pseudo-random data. All right. In this lecture, we'll explore several functions that quickly generate arrays of data in NumPy. As the heading in the Python notebook suggests, these are npempty, np0s, np1s, and npfull. We'll explain what each one does and test it out ourselves. Let's begin. Good practice dictates importing your packages at the start of every notebook. So let's import NumPy now. Good. Next comes the first function on our agenda, npempty. This function creates an empty nd array of a given shape and type. However, empty doesn't really exist in programming. So what this method does is return an array of the aforementioned shape without initializing entries. Since the function doesn't have to assign values to each element, it's the fastest way to generate an nd array. Let's create a variable called arrayEmpty and set it equal to npempty. Then, in the parentheses, set the shape argument equal to the tuple 2, 3. Since data type is an optional argument, we can call the function without specifying it. To see if we've successfully generated an array, we'll display it on the next line. Usually, this results in an array of zeros. However, it's possible to get some random numbers instead. What really happens is that an array is created and is assigned some memory from our RAM. This happens so NumPy could be more efficient. No new information is created, but rather some old one is allocated. This is one of the cons of using the empty function, since it doesn't produce consistent output. Thus, we're sometimes better off sacrificing speed for accuracy, which brings us to the next function on the list, np0s. As you can guess, this function creates an array full of zeros with a given shape and type. Once we define a variable with an appropriate name, we set it equal to the function. Then, in the parentheses, we specify the same shape as before. As always, we call the newly created variable on the next line to examine our output. Just as expected, the output is an array of zeros. The only difference here is that the output of this code will always be an array of zeros. Great! We didn't take advantage of this for npempty, but let's see what happens when we specify a data type for the values of the array. We can set the dtype argument equal to np int 8 and see what happens. The new array still contains zeros, but now they are whole numbers rather than floats, and we see the data type specified at the end. This is done to showcase when the data type is different from the default, so we can avoid making errors. Good job so far! The next function we want to briefly go over is np1s. It's just the one equivalent to np0s and works the exact same way. It generates an array of ones over a given shape and type. Since its syntax is identical to that of np0s, we can copy the code we just ran into a new cell, change the name of the variable and the function, and execute. Once again, the output is exactly what we'd expect. So there's nothing too fancy to see here. The last function we want to examine is npfull. It generates an array with a given shape filled entirely with a specified value. Unlike the function so far, it contains an additional mandatory argument called fillValue, which takes scalar values. Since it's not optional, we need to pass a value to it before running the function. Otherwise, we'll get an error message. Let's generate an array full of 2s. To do so, we create a variable with a suitable name and set it equal to npfull. Then, within the parentheses, we define the shape to be a 2 by 3 array. If we run the cell now, we'll get a type error message since we haven't specified anything for fillValue. So we'd better set the fillValue argument to 2 and run the cell again. The output is just what we wanted, so the fillValue method works as intended. Notice how we said fillValue takes a scalar rather than a number? Well, that's because we can also set it equal to other values. For example, some text messages like 365 See? The output is still an array of the proper shape with the string in each position. However, we probably won't need to use that too often, since NumPy is much better suited to working with numerical data. Splendid work, everyone! Now that we've learned some of the quickest ways of generating arrays with a predetermined shape, we're ready to examine how to do so without specifying it. In the next lecture, we'll go over like functions and discuss when we want to use them. Thanks for watching!